Now we're going to look at some terms and definitions that are going to be helpful in the upcoming theorems and corollaries. And so let's talk about distance first before we get into some polygons now. And we're going to be mainly looking at only quadrilaterals in the next few theorems. But distance will also help us when we go through some of these theorems. There are three kinds of definitions when it comes to distance, because you can have a distance between 2 points, you can have a distance between a point and a line, and distance between two parallel lines. And so the distance between 2 points, earlier we've talked about how you can have the shortest distance between 2 points is a straight line. So the distance between 2 points is a straight line joining those 2 points, joining the 2 points. And so that is the distance. Whenever we talk about the distance between two separate points, we are talking about that straight line between. We might have to draw an auxiliary line between, or it's just understood when we say the word distance between those 2 points that we might be talking about, we're talking about the distance that a straight line would take between those 2 points. The distance between a point and a line. We've talked about also that a perpendicular, if we want to find the shortest distance between a point and a given line, it would be a perpendicular to that line. So the distance between a point and a line is the perpendicular to that line, from the given point, So, for example, let's just quickly do something like this. If we had a point here, and we said, what's the distance from that point to the line? We would draw a straight line that's perpendicular to the given line, and this would be the distance. We wouldn't be talking about from this point coming over here. That's not the distance. That is a distance from that point, but it's not what we would be referring to. It's the shortest, again, distance from that point to a given line. All right, and then lastly, the distance between two parallel lines is the distance from one of the lines perpendicular to the other. And so again, if we had quickly two parallel lines, we can pick any point in one of the lines and draw a perpendicular to the other line. We can't necessarily say it's perpendicular to the first line that it came from. We could prove it, but by definition, we're only saying it's perpendicular to one of those perpendicular lines. We could draw from a point in this parallel line to the other one and say it's perpendicular to that one. And again, we could prove that both, it's perpendicular to both, but by definition, we're not saying that. All right, perfect. Now let's talk about some quadrilaterals. We're going to end up talking about parallelograms. A quadrilateral, let's define it, and you can see that I have just made an abbreviation. Instead of saying quadrilateral in our proofs, I'm pretty much just going to be talking about quads. I'm going to write down quad, but I'm referring to quadrilaterals. Quadrilaterals is simply a polygon. I'm going to say a p-gon, and sometimes you might put a dash in between the p and the g. A polygon of 4 sides. And we have a polygon here, A, B, C, D. We can label it, or we can state it by saying quad A, B, C, D, or you could even say quad AC by the opposite vertices. You could say AC, you could also say quad BD, DB, however you'd like to say it. Usually we want to go in alphabetical order, but I'm not one of those people who will martyr someone if they accidentally say CA, quad CA. Oh, okay. Tomatoes. I know some people are pretty big sticklers on that. So that's a quadrilateral, just any kind of polygon that has 4 sides. All right, a parallelogram. Let's define parallelogram. It's a quadrilateral. So again, I'm not going to write out quadrilateral. Quadrilateral whose opposite sides are parallel. If we have a polygon of 4 sides, which is a quadrilateral, and the opposite sides are parallel, so AB would be parallel to DC, and the other opposite sides, AD and BC, are also parallel. There we go. And for sake of quickness, I'm going to use the abbreviation here, parallelogram. I'm going to pretty much draw a small parallelogram, and we could do the same kind of thing. This would be parallelogram ABCD, or parallelogram AC, or parallelogram BD, something like that. Okay, pretty simple. Any side to a parallelogram could be considered its base. Usually it's the side that it appears to be resting on, but any side could be the base. And then if we were to draw Then if we were to draw a straight line from any vertex perpendicular to the opposite side, this would be called the altitude. Altitude. There we go. Some may put it from any point on from the opposite side. You could have a point, I don't know, N here. Let's make it capital. Usually, it's going to come from a vertex of the quadrilateral. So that would be called the altitude, a line from a vertex to the opposite side, and it's perpendicular to that opposite side. Okay, rhombus. A rhombus, it's not necessarily the kind of definition that we are necessarily used to. We are going to define a rhombus as a parallelogram having 2 adjacent sides equal. We're not going to state that all 4 sides are equal. We're actually going to end up proving that a rhombus has all 4 sides equal. By definition, we're going to state that this is a parallelogram. That means it's a quadrilateral having opposite sides parallel to each other. And now on top of that, we're saying that it has 2 adjacent sides. So we don't have to choose these 2 sides. We could choose these 2 adjacent sides. We could choose these 2 adjacent sides, or those 2 adjacent sides. Any 2 adjacent sides are equal in a rhombus. All right, number 5, the 5th definition we'll talk about is a rectangle. A rectangle is a parallelogram having, or I'll say one of whose angles is a right angle. All right, so again, opposite sides parallel, parallelogram. And then also it has at least one right angle. We are not stating that all of these are right angles. Again, we can prove it, but by definition, we're going to state that it's a parallelogram that has one right angle. And then lastly, square. A square is a rectangle. So we know that it has one right angle. A rectangle having 2 adjacent sides equal. Kind of what we said for a rhombus. So it's pretty much a rectangle and a rhombus combined. So we have one right angle and 2 adjacent sides equal. And that's all we are going to state that a square is.